This is the Unit 10 second semester final review. We're now looking at number 18. So we first have to simplify with no negative exponents. So I'll just kind of first look at this, and if it's a negative, I'm going to move it across the fraction. So the x squared is going to stay there. Y to the negative fourth, I'm going to move down, makes that positive. X to the negative third, I'm going to move up. And y to the negative sixth, I move up, makes them positive. So from there, I can start to piece them together. I have x to the fifth on top, because I have 5 x's. And then I have y to the 6th and y to the 4th. Well, there's 2 more y's on top, so I'll make it y squared. So it's x to the 5th, y squared. For b, I'm first going to have to distribute this cubed out inside the parentheses. I get negative 2 to the 3rd, a to the 3rd, and then b to the negative 2 to the 3rd becomes b to the negative 6th. Now when I bring down everything else, I see I have a negative 2 to the 3rd, which is negative 8. That's going to go out in front. I have an a to the 3rd and a to the 3rd, which becomes a to the 6th. And I have b to the negative 7th, negative 6th, and to the 1st. So in combining those together, I get negative 8, a to the 6th, b to the negative 12th, which I'm now going to move that underneath and make it b to the 12th, making it positive down below. For 19, I have to simplify to have no radicals and have rational exponents in the form a to the exponent b to the c, b over c. So this x to the 2/3, the 6th root means 1/6, and so I'm going to multiply these two because it's an exponent to an exponent. 2/3 times 1/6 becomes 2 over 18, which is 1/9, so I make it x to the 1/9. 6 to the 1/10 times 6 to the 3/5. Since they're separate exponents, I'm going to add 1/10 plus 3/5, which I can make 1/10 plus 6/10, and this becomes 6 to the 7/10. For c, I'm going to multiply because it's an exponent to an exponent, so it's 1/3 times 2, or 2 over 1. That becomes x to the 2/3. Number 20, I have 16 to the 3 over 2. I could write this as 2 ways. I could write it as the square root of 16 cubed, or it's 16 to the 3rd, the square root. The one on the left's a little bit nicer because the square root of 16 is 4. That becomes 4 to the 3rd, and 4 to the 3rd is 64. On b, I'm going to rearrange the order, and I'm going to make it now the cube root of 27 squared. Because the cube root of 27 is 3, 3 squared is then 9. For 18, 18 is 9 times 2. So I can take the 9 and notice that it's 3 times 3. I can take those out and write it as 3 root 2, and that's what we call simplified radical form. Now we look at 21. We have root 3, root 7, square root of 11, and square root of 13. I need to figure out if their statements are true or false. Are they all real numbers? Yes, they are. That's true. Are they all rational numbers? They are not. They are not rational because we call them irrational. So that's going to be true. And are they integers? Integers are typically, we think of as whole numbers. These are not. They don't simplify. If they were perfect squares, yes, but not in this case. 22, I need to simplify and leave in radical form. So when I have numbers on the outside, I'm going to multiply them together. And when I have numbers in the radical, I'm going to multiply them together. So 5 and negative 2, I make into negative 10. 3 and 7 go inside, I make it into the square root of 21. Square root of 21 doesn't simplify, we leave it as that. Next one, I have negative 5 and 7 become negative 35. 12 and 3 is 36. Well, that actually simplifies because the square root of 36 is 6. So now my answer is going to be, oops, so about 35 down, not the 36. Now it's going to be 35 times 6 and a negative 210. For this one, I'm going to divide. 6 divided by 3 is 2, and then 45 divided by 5, as long as it's in the radical, is a 9. But 2 times the square root of 9 is 2 times 3, and we get an answer of 6. For D, I'm going to combine like terms. I have 8 and 5 is 13. Now, I'm really looking at the coefficients on these. I'm not going to make it root 6. What I'm saying is I have 2 root 3s. So I'll write as 13 plus 2 root 3. E is a little different. We just got to make sure we distribute out the negative. I'm going to make it negative 5 plus 2 root 13. It's really, are you paying attention to that second negative in the subtraction? 7 minus 5 is 2, and then negative 9 and positive 2 is a negative 7, so it's going to be 2 minus 7 root 13. 23, all of them have the same base. It's 11 to the 3/5 times 11 to the 4 over x equals 11 to the 7/5. So in doing that, I can just make it into the equation 3/5 plus 4 over x equals 7 over 5. Because these exponents need to add to equal that one. So we drop the base off of there, and we look, well, 3 and 4 add to 7, but that's only going to work if this is 5 and they have like denominators. Since that's the case, we're going to say x equals 5. For B, I'm going to first change them all to exponential. I have 7 to the 5 over 12 over 7 to the 1/3 equals 7 over 1 to the x. Now, when it's division, I can make it into subtraction. So that's 7 to the 5/12 minus 7 to the 1/3 equals 7 to the 1 over x. I'm not real sure what that denominator needs to be, so I'm going to make this into a like denominator, and maybe I can simplify. So that needs to be over 12. To do that, I multiply it by 4. And now I have 5/12. It would be 5/12 minus, really I should drop these off here and just have, got ahead of myself, just looking at the exponents if I'm get rid of those because it's not really subtraction. But 5/12 minus 4/12 equals 1 over x. Well, 5 minus 4 is 1, so 1/12 equals 1 over x. X should equal 12. In number 24, we need to select all the equations that are equivalent to what we had here. So I'm going to first kind of play with this one and make it 8 to the 2/3, and that's going to be x to the 4/3. 8 to the 2/3, I could take the cube root of 8, and that's 2. So this could be 2 squared or 4. And that's going to help me and go through and eliminate some answers. So I want to look for ones that have constants of 4, and those are going to work. Or I find the ones that don't, and I can just eliminate them. Like this one right here, I have the cube root of 8. That is not going to come out to 4. That'll come out to 2. So that one's gone. This one's going to be the cube root of 2. That one's not going to work. That one has a 4. Okay. That one has a 4. All right. This one, I'm going to take the cube root of 8, get 2, square it, and it would come out to be 4. So that one's a maybe. So those are the ones that at least work. Now, I go to x to the 4/3. This is x to the 4 over 3. We said it worked already, so we'll take D. This is 4x and x to the 1/3. Together, I have 1 plus 1/3, which is 4/3. So that one is true. And here, I have x to the 4th, because it's x squared squared. And then the cube root becomes 3. That'd be x to the 4/3 as well. So we'd say A, C, and D. Again, I recommend on this one, eliminate the ones you know don't work. Start with like the constant out in front, the coefficient. It makes it a little bit easier to clean up. Next one, let's look at simplifying. Both of them are going to have the 4th root. So let's go 2 to the 1/4 x to the 2/4 times 2 to the 1/4 x to the 3/4. Now, I can put these together, and that's going to be 2 to the 2/4, or 2 to the 1/2. I can put these together, and that's going to be 3 to the 5/4, or x to the 5/4. I don't know where I got 3 from. So 2 to the 1/2, x to the 5/4, that actually matches B, because they actually didn't reduce the 2 over 4, and that's the one we want. We'll go to 26. Now I'm going to multiply these out in front, and that's going to be 1/9, and it's going to be x to the 1/4 plus 2/3. So here, if I add 1/4 and 2/3, they need to have a denominator of 12, so that's 3/12 plus 8/12, which is 11/12. So I got 1/9 x to the 11/12, which I could also maybe see as 1/9 the 12th root of x to the 11th, which I see there as answer C. For 27, I'm going to write them all in exponential form. So I got x to the 1/3 times x, or 8 to the 2/3 plus 8 squared. I'm then going to distribute in these by adding exponents. So I get 8 to the 1/3 plus 2/3 plus 8 to the 1/3 plus 2. This becomes 8. And then here we have 1/3 plus 2 is really 1/3 plus 6/3 or 7/3. So looking through, I got a 8 to the 7/3, 8 to the 7/3. So those are at least in, but I need an 8. Well, this one, trying to trick us, is actually 8 to the 3/3. It would work. Our answer is going to be C. For our next one, we got 5 to the 3/8 times 5 to the 2/4. Let's combine those. I could write 3/8 plus, let's make that 8s and make it 4/8. So that's 5 to the 7/8, which is the answer of D. For 29, we have the numbers 2, 7, root 2, root 7, 2 root 7, and 2 minus root 7. Choose two numbers that when we multiply them, it is irrational, and when you add the same two numbers, it is rational. So we need to multiply to get an irrational, but add them to get a rational. Well, I know I'm not going to use my whole numbers. If I'm multiplying to get an irrational, they need to be square roots. But if I look at root 7 and 2 minus root 7, if I add those together, that leaves me with a 2. If I multiply them, it gives me 2 root 7 minus, looks like 7. So those two would work there. B, multiply them, it's rational, but add, they're irrational. So I want to look for 2 I can multiply, and it gets rid of the square root. And in that case, I see root 7 and 2 root 7. Because in multiplying those together, it comes out to be 14, because it's 2 times 7. But in adding them, it's going to be 2 root 7 plus root 7, it'll be 3 root 7. For C, I multiply them, they're irrational. I add, they're irrational. So when is it not going to work? Well, root 2 and root 7 seem to fit that. When I multiply them, it's the square root of 14. When I add them, it's root 2 plus root 7. It's also irrational. So those are the ones that fit. For number 30, we need to choose all false statements and then correct them if it is false. So what we'll do is we'll simplify, see if it works, and if in doing that, if it turns out false, we'll have the correct answer. So for A, I have x to the 6th over x squared. In doing that one, I'm going to simplify it. I have 6 on top, 2 on the bottom. That's actually x to the 4th, and that is not equal to x to the 3rd. So that one is a false. It should be x to the 4th. For this one, I have y squared to the 4th, so that means I have 4y squareds, so I have y to the 8th, and that is not equal to y to the 6th, so that one is also false. B to the -3 means if it's negative, I move it underneath the fraction to make it a positive exponent, then that is not true, so that one is false. For D, I'm going to distribute the exponent out. X to the 4th is x to the 16th. Y to the 3rd to the 4th is y to the 12th, and then I have an x to the 4th. I combine the x's, and I get x to the 20th, y to the 12th, and that one does turn out to be true. And the last one is b to the -5 to the 4th, means I have b to the -20th, and that is not equal to b to the -1st. So A, B, C, and E are all false. Let me move that one over. There we go. Okay, simplify the expression, then select the ones that are irrational for our last one here. I'm going to multiply. I get 15 times the square root of 36, because that's 2 times 18. And that's 15 times 6, which is 90. So that comes out to be 90. That is not irrational. 7 times 36, square root of 36 is 6, and that comes out to be 42. That is not irrational. When I divide root 15 over root 3, I'm left with root 5, and that is irrational. 4 times, I'm going to write this as the cube root of 27 squared. The cube root of 27 is 3. 3 squared is 9, so I get 36, and that is a rational number, or not irrational. The last one here, I can't really combine these two. I guess I could go like 3 root 2 and make this a, let's see, root 18 is 9 times 2, so that's 3 root 2. So I could go 5 times 3 root 2, make it 15 and 8, 3 is 18 root 2, but that is just going to stay as irrational. We are now on to Unit 11 for the second semester final review. So for 32a, we're looking at combining like terms. I have 5x squared and 2x squared. Those will combine to be a 7x squared. I have a 3x, which is just the lone 3x. And then negative 7 and negative 8 combine to be negative 15. They're all separate, unlike terms. Can't combine any further, so I'm done. Now what we have to be careful with is b, because I have this subtraction right here, and it's actually minus 2x squared plus 8, which is something we have to be careful with, that distributing out the negative. So now it's 5x squared minus 2x squared, which is 3x squared. 3x is still by itself, and then negative 7 plus 8 turns out to be 1. For c, we're going to distribute the 5x squared y to each term. Be careful going through, making sure you get your coefficients and your exponents correct. For the first one, it's 5 times 7 is 35. Then I have x squared, and x to the third is x to the fifth, and a lone y. Next one is going to be negative 20. X squared and x is x to the third. Y and y is y squared. And last is negative 5x squared y. For d, I'm going to do distributive property first, and then combine like terms. I get 12c to the third minus 15c. For the last term, I'm going to get a negative 9c squared. Now I look here, see if I can combine anything. I got a c to the third, a c, and a c squared. So we're just going to make it 12c to the third minus 9c squared minus 15c by just making it in descending order. Now for e, I'm going to multiply, and since I have a coefficient in front of each of the x's, I'm going to use the box to multiply. You could also use FOIL, but I'm really, I prefer the box method when solving. I think it keeps things organized, but well, if you're in my class, you already know that. So we're going to multiply. 3x and 2x gives us 6x squared. 2x and 5 is 10x. 3x and negative 7 is negative 21x, and then a negative 35. So when I look at my terms, I have a 6x squared. 10x and negative 21x is negative 11x, and then last minus 35. For f, I'm going to make a 3 by 2 box because I have 3 terms in one of my polynomials. And that's going to be 3x squared, x and minus 4, 2x and minus 5. So I have 6x to the third, 2x squared minus 8x, a negative 15x squared, negative 5x, and a 20. So combining like terms, I get 6x to the third. We have a negative 15 and a 2 for our x squared coefficients, so that's negative 13x squared. A negative 5 and a negative 8 is a negative 13x, and then last plus 20. For g, we got to be careful and not make it 9x squared plus 121. It's not distributing in the square root because it is addition. If it was multiplication, maybe like something we would have done back in Unit 10, that's a different case. But this, we got to get in the habit of writing it as 3x plus 11 times 3x plus 11. So we make it to the box. We get 9x squared, 33x, 33x, and 121. So our answer is 9x squared. 33 and 33 is 66x, and then 121. For h, I'm going to do the same idea and multiply 5y minus 1 times itself first. So take care of these two. I get 25y squared minus 5y minus 5y and 1. So that comes out to be 25y squared minus 10y plus 1. Now, I bring down the 2 that was out in front, and I need to distribute it in, and it becomes 50y squared minus 20y plus 2. For I, if I do the box, I squared plus 3 and or x squared plus 3 and x squared minus 3, I get x to the fourth, 3x squared, negative 3x squared, and a negative 9. My like terms, the 3x squared and negative 3x squared, actually become 0. So it's x to the fourth minus 9. Last for j, it's going to be combining some terms here. I'm going to go through and make this negative 11x plus 3. I don't want to forget to distribute the negative out. And really I look, my largest exponent is an x squared. I got an x, and I'm going to have a constant. So I need to figure out how much I have of each. So I have 4x squared and 9x squared, so that gives me 13x squared. I'm going to cross those out. Now I have negative 5, negative 2, and negative 11, and that looks like a negative 18. Cross those out. I'm left with 6 and 3 is a 9, so my answer is 13x squared minus 18x plus 9. For k, I have 3 binomials, and I'm just going to pick 2 of them to multiply first, and then whatever result I get from that, I'm going to multiply the last one to there. And so if I take these first 2 and multiply x plus 6 and x minus 2, I get x squared, 6x minus 2x and minus 12, to get x squared plus 4x minus 12. I then bring down the 3x plus 1, and I'm going to multiply this now, so it's x squared plus 4x minus 12. And then we have a 3x plus 1. Gives us 3x cubed, 12x squared, minus 36x, x squared, 4x, and minus 12. Combining my terms, I have 3x cubed. X squared and 12x is 13x. Negative 36x and 4 is negative 32x, and then the negative 12 on the end. Now we shift gears and we look at factoring. So that was kind of the other portion we looked in this chapter. So I'm going to look at 33a first. I look and see a common factor of 5 and an x in all of them. So if I take that out of each term, I'm left with x squared plus 5x minus 9. So it was a factor, and that is the greatest common factor. What I have left, if I look, multiplies to negative 9, that adds to 5. I don't really have anything that does that, so this is actually it factored completely. It's not that it's not factorable because I'm stuck with this. It's the fact we have a 5x, and that was the common factor. Now we go to b, and we're looking to multiply to 10 that adds to 7. So if I do 5 times 2, it gives me 10, then 5 plus 2 is 7. So I'm going to do x plus 5, x plus 2. For c, I have x squared plus 2x minus 15, multiply to 15, add, or multiply to negative 15, add to 2. Since 1 is negative, the multiply is negative, and it's a positive sum, I got a positive and a negative number. Now, I need to figure out which ones are 2 numbers apart, the factors. So 15, if I do 5 and 3, those are 2 apart, so if I do positive 5, negative 3, they add to be 2. So now it's going to be x plus 5, x minus 3. For d, multiply to 36, add to 9. A negative product, but a positive sum means one's positive, one's negative. So I need them to be 9 apart. Well, 6 times 6 is usually the first one we think of for 36, and those are not 9 apart, they're the same number. But if I think of 12 and 3, those are 9 apart. So if I go positive 12, negative 3, those add to 9. So it's x plus 12, x minus 3. For e, I'm looking at multiplying to negative 21 that adds to negative 4. So they're both negative. So for something to multiply, 2 numbers to multiply to be negative, one's positive, one's negative, but since they add to a negative, the negative number is going to be the bigger one. They still got to be 4 apart though. So for 21, 7 and 3 are probably the first ones we think of. They are 4 apart, so we're going to have to go -7, +3, which we check. That does add to -4. So it'll be y plus 3, y minus 7. Now for this last one, we're still going to follow the same process we have been doing and look at 32, multiply to 32, add to 12. 32, we could do 8 and 4, which happens to add to 12, so we'll do 8 and 4. But instead of just being like something a plus 8, a plus 4, the fact we have these b's here means it's going to be attached to the second term in each binomial. So I'm going to make it a plus 8b and a plus 4b. They still multiply, so if I multiply these two and went in reverse, it would give us 32b squared. If I add them, it gives me 12, it would be 12ab if we went in reverse to multiply, and then the a squared. So these would be our two factors. Notice I had the b squared on the other end opposite to the a squared. It's just the way that it will work out for us. Now for g, I'm going to factor out a 2, and I get g squared minus 18g plus 45. Now I want to multiply to 45, that adds to 18. So multiply to 45 adds to 18. I'm just going to draw out some, or I'm going to add to -18. So if it's a -18, it means they're both negative. So if I can just write out some factors, I want to find ones that are together add to 18. So 45, I got 9 and 5. Those add to 13. I could do 3 and 15. I can do 1 and 45. These two stick out because if I do 3 times 15, I get 45. But if I do negatives, then they would add to -18. So that become 2 times g minus 3, g minus 15. For h, I'm going to multiply these two. I'm going to multiply to -30, and I want to add to 7. So it's a negative product. So one's positive, one's negative. Add to 7, it looks like I do +10, -3. Now what I'm not going to do is make it x plus 10, x minus 3. I have to now split this term, and I do that now because I have a coefficient out in front of the x squared, which happens to be a 6. So when that happens, this is the process we're going to do. I'm going to go 6x squared, break apart 7x into plus 10x, minus 3x, minus 5. Now we do something called factor by grouping. I'm going to factor the first two terms together. I can take out a 2x, and I get 3x plus 5. The last two terms, I can take out a -1, and I get 3x plus 5. The key thing is these two match. So I take that out now. 3x plus 5 are matching terms, and then our leftovers are 2x minus 1. Now for I, I'm looking to multiply to 10, and it adds to 11. Well, that one, 10 and 1, would fit that. So we're going to go 5y squared plus 10y plus y plus 2. I can factor out a 5y for the first one. I get y plus 2. Can't factor anything out of the second one, so it's actually just like factoring a 1 out. So my factors are y plus 2 and 5y plus 1. For k, I'm looking at multiplying to 49. That adds to -14. So 7 and 7 would give me 49. So I can make these x minus 7, x minus 7, which together would be x minus 7 squared. For L, I'm going to factor out a 5a, because it's the common factors, leaves me with a squared plus 6a plus 9. Multiply to 9 adds to 6. That's going to be 3 and 3, so I could go a plus 3, a plus 3, or just write it as 5a times a plus 3 squared. M is a difference of two squares. We recognize it because it's two terms and they're both perfect squares. So this one's going to be 3x minus 5, 3x plus 5. Expression that is equivalent. I could multiply these all out, but I'm going to do something first and notice they both have an x plus 7 in them. So I could take the x plus 7 out of each of them. That leaves me with one x plus 7 here minus x minus 2 because that one is gone. So it's like the squared one is gone and that one is gone. So that is actually what this answer is. Now once we take it out, it matches. We're not going to be able to get rid of this x plus 7, so that's why this answer does not work. We could multiply it together and see what it comes out to, so let's do that. So then we have x plus 7, and then in this parenthesis, x minus x is 0, 7 minus a negative 2 is 9, so then it's going to be x plus 7 times 9, which is not that, and it's certainly not that, so D would be our best answer. Last one, 35, we have to find the first box and last box. Now I could go through multiplying all of this, but I'm going to kind of cheat a little bit. Because in order to get this front coefficient, it's really going to be 3 times 4, and then times the 2. Yeah, all the other stuff will work out, but 2 times 4 times 3 gives me 24. And then to find the end term, the constant, it's going to be the 5 times the 3 times the 2. So 3 times 5 times 2 gives me 30. This is the Unit 2, or Unit 12 of the second semester final review. We've reached the final chapter. So in 36, we're given our function f of x equals x plus 2 squared minus 3. Now this is in the vertex form, which is really nice to pull the vertex from. We change our value on the inside and make that a negative 2. Bring the negative 3 down, keep it the same, and that is the vertex for this. So I go to negative 2, negative 3. It's as easy as that in vertex form. When it's in this form, you change the x value, keep the y value the same, you got your vertex. You blink, you might miss it. Now this one, since I have no negative right here, I know that it opens up. So that's taken care of. My domain of f of x, my domain of any of these parabolas is all real numbers, so we'll write all reals. My range, though, depends on where the y value is. So from the vertex, I get this negative 3. So my y values are in relation to this negative 3. They're all either all above it or all below it. Now the fact I know the parabola opens up, it's going to go in this direction. That means my y values are all greater than or equal to negative 3. Now, we got that from the y value of the vertex. The next one, the line of symmetry, is the x value in the vertex, which is negative 2. So if we draw this through here, that is your axis of symmetry. Now we said it did open up, so that means our vertex is a minimum. So now we can go through and graph this. Let's pick some points to plot. If I did, this is x and f of x. Let's try x is 0. If x is 0, I have 2 squared, which is 4, minus 3 is 1. So I know it hits there. If x is negative 1, negative 1 and 2 is 1. 1 squared is 1. And then minus 3 is negative 2, which would be right here. Now, that gives me a start of the parabola. And what I can use to help me out, because it is a parabola and it's symmetric, if I go 1 unit on the other side, 2 units away on the other side, I then have our sketch to work with. Now, on the same graph, they want us to graph g of x. Let me get a different pen. So g of x has a vertex at 4, 2, because we changed the sign, keep it the same. Its maximum, because it is going down, is the y value of 2. Its domain is all reals again. Since your range, we have a value of 2, and it goes down, it's going to be less than or equal to 2. Our line of symmetry is the x value, so that is when x equals 4. We should probably sketch this graph. We said the vertex is at 4, 2. It's going down. Let's pick some points here. So this is x and g of x. I'm going to plug in, let's go with like a 3. Because this, if we plug in 3, we get 3 minus 4 is 1, 1 squared. And then times negative 2, this comes out to be 0. So it hits at 3, 0. If it hits there, it also hits on the other side of our axis of symmetry. Let's go to 2, plug 2 in. x minus 2 is negative 2, squared is 4, which is negative 8, plus 2 is negative 6. So then we're going down 6 to here. And there's our graph of g of x. This is okay. If we want to check if negative 6 is a solution, all that means is we're going to plug it into our equation and see if that works. So let's go negative 6 would be our y value, or g of x. Negative 2, then we'll do 6 minus 4 squared plus 2. So all of this has to come out to be negative 6. Well, 6 minus 4 is 2. 2 squared is 4. 4 times negative 2 is negative 8 plus 2. And it looks like that comes out to be negative 6, so it matches, so we'll say yes. And then it wants to know two other solutions that we have. Now we kind of did this work already over here. We know that 3, 0, and then 2, negative 6 would work. But really you could pick any x values to plug in. That'd be your x value, and then your y value would be the result that you get. Now the descriptive form of this parabola in this form is best to determine the vertex, which we kind of already mentioned. It's also good, we could maybe say like the min and max is good, the direction, the range. I'm not really sure how much more they want, but really that vertex is the big one we get from it that's quite nice. If we go down to 37, we have the equation x squared minus 2x minus 8. We need to find the vertex. To do that, we actually find the line of symmetry first, which is x equals negative b over 2a. And that's going to be negative negative 2 over 2 times 1, which is 2 over 2. It comes out to be 1, which is our x value. We then plug that back into our equation. And so it's 1 squared minus 2 minus 8. Looks like it's going to be a negative 9. Now, explain how you get the line of symmetry. We kind of mentioned that x equals negative b over 2a is what you're going to use. They want us to now graph this. And let's get some easy stuff out of the way. We know the y-intercept is negative 8 because we make the x is 0 and we get there. So 0, negative 8 we have. 1 goes to negative 9. We got that as well. Jumping down here to factor, this will help us a little bit. Multiplying to negative 8 adds to negative 2. I could do x minus 4, x plus 2. What's nice about that is then I know I have two solutions at 4 and negative 2, which are actually our x-intercepts. So up here on our table, whenever it's 4, we get 0. When it's negative 2, we get 0. And also cheating a little bit, since this is our vertex, we know it's symmetric on either side. So if I plugged a 2 in, I would also get negative 8. Now I can plug a negative 1 in up here, and I would get 1 plus 2 minus 8, which would be negative 5, which is either side of those. We keep going. This one, plugging in, would be a 7, and then I believe we'd have 32 for those. Now, we can plot these. We got 4, 0, 3, negative 5, 2, negative 8. We're kind of off the grid here. And we can see this is where the parabola fits. Okay, what is the relationship between the factors and the x-intercepts? If you notice, when you get your factors equal to 0, using the zero product property, it gets you to say x minus 4 equals 0, x plus 2 equals 0, which gives you your solutions or your factors that you have. So you set the factors equal to 0, and that gives you your solutions. It's probably the better way to write it there. Now, the standard form of the parabola is the best way to reveal the value of the, I would say, the y-intercept without changing anything, because again, we can just make the x is 0. It automatically gives us the y-intercept. Now f, on the other hand, when it's in that factored form already, this is definitely the best way to find the x-intercept, or like it calls it, the zeros or the solutions of the equation. Okay, on 38, we're going to graph x squared, which looks like this. Okay, and then we need to sketch the translation that if we went plus x plus 3, y minus 2. Now if I add 3 to x, it means I move 3 to the right, and 2 to y means I move down 2. So I'm going to take and move everything over 3, down 2, so my vertex is here. Now it still follows the same pattern. It goes up 1, or over 1, up 1, over 2, up 4. It still has the same shape, but it was shifted. So if we wrote that out, this would be f of x, I guess I want t of x. T of x equals, I would go a x minus 3 squared plus or minus 2. Okay, that is the vertex form that we had earlier. Remember, we changed the sign, make it a negative 3, and then squared minus 2. Now r of x, which was right here, is decreasing when x is less than 0, because it's going down right here. Anytime to the left side of the vertex, it's going down. And that means it is increasing when it is bigger. So that's going to be going up. So now we're going to find the solutions for the equations that we have. Let's start with 2x squared minus 18. First thing I'm going to do is factor out a 2. And I'm left with x squared minus 9 equals 0. Now the 2 is not a factor in terms of solving for x. It actually can now be divided from both sides. And now you're left with x squared minus 9 equals 0. It's when x equals something that we'd say it's a solution. 2 is just a factor we can get rid of. Now x squared minus 9 is a difference of 2 squares. And that becomes x minus 3, x plus 3 equals 0. So we say x minus 3 equals 0, which tells us positive 3. And x plus 3 equals 0, which gives us negative 3. So our two solutions are 3 and negative 3. For b, what could we divide out? Maybe we can divide out a 3, and I get 25x squared plus 16 equals 0. Once this is out, I divide both sides by 3, and it gives me just that. I'm going to move the 25 or the 16 over to the other side. Now I can take the square root of both sides, and I get 5x squared equals plus or minus the square root of negative 16, which this negative 16 in the radical becomes plus or minus 4i. Should be a 5x squared, just a 5x. Equals 5x. Now when I divide it over, I get x equals plus or minus 4i over 5. So these are imaginary solutions, plus or minus 4i over 5 for number 29, B. X squared minus 4x minus 21. So if we first look at factoring, I'm looking at multiplying to negative 21 that adds to negative 4. 7 and 3 come to mind. If I make it a negative 7, that would add up to be negative 4, multiplies to negative 21. So we're going to go x minus 7, x plus 3 equals 0. I then set them both equal to 0 and get x equals positive 7 and x equals negative 3. So those are my two solutions there. For D, I'm going to first divide out a 2 from everything, and I get x squared plus 9x plus 20 equals 0. The 2 is going to be gone because it's divided away. I'm looking at multiplying to 20. That adds to 9. 5 and 4 looks like they'd work. So we go x plus 5, x plus 4. So then we're going to say x plus 5 equals 0, so x equals negative 5. X plus 4 equals 0, x equals negative 4. Our two solutions are negative 5 and negative 4. For E, we need to factor this one. Multiplies to 36, adds to negative 15. let's see, 36, we could do like 3 and 12, and if they're both negative, they would then add up to negative 15 and multiply to 36. So by factoring this one, we're going to go 2x squared minus 3x minus 12x plus 18 equals 0. This is factoring by grouping. Okay? If you have other methods to factor in the trinomial like this, it'd be good to get to that as well. X comes out, I got 2x minus 3. In negative 12x plus 18, I can take out a negative 6, and I'm left with 2x minus 3. I take the first, or the common terms, that's 2x minus 3, and the leftovers, x minus 6. So now I can say 2x minus 3 equals 0, which becomes 2x equals 3, and x equals 3 over 2, or x minus 6 equals 0, and x equals 6. So our two solutions are 3 over 2, and x equals 6. For f, first thing I'm going to do is move over the 10. So that becomes a positive 10 equals 0 on this side. And what we can do here, multiplies to 30, adds to 17. Why don't we use quadratic formula? You could factor it, and that's perfectly fine, but I want to show a quadratic formula example, because that is an option here. You could always look quadratic. So if we did quadratic formula, which is negative b plus or minus b squared minus 4ac over 2a. Either method, factoring quadratic, will get you to the same result, but it just depends on your preference. So we're going to go negative 17 plus or minus the square root of 17 squared minus 4 times 3 times 10 over 2 times 3. So we got negative 17 plus or minus 17 squared is 289. And that's going to be minus 120 over 6. So we're going to go negative 17 plus or minus, this looks like 169 over 6. Now I know 169 is a perfect square. It is 13. So now our two options are negative 17 plus 13 over 6 and negative 17 minus 13 over 6. Well, the top one becomes negative 4 over 6, or negative 2/3. The bottom one becomes negative 30 over 6, or negative 5. So our two solutions in this case, x equals negative 2/3 and negative 5. Now, if you went through and factored it, and you want to make sure you have the right result, you would have had 3x plus 2 and x plus 5 equals 0, then you would have set them each equal to 0 and solve, but that's if you went the factoring out to make sure you got to the correct factored result. It was negative 2/3 and negative 5. All right, for g, let's go quadratic formula again. So we're going to go x equals negative 5 plus or minus the square root of 5 squared minus 4 times 2 times 1 over 2 times 2. Negative 5 plus or minus the square root of 25 minus 8 over 4. Negative 5 plus or minus the square root of 17 over 4. This one we can't simplify anymore, but we do have two solutions. It's negative 5 plus the square root of 17 over 4 and negative 5 minus the square root of 17 over 4. Now for h, we'll go quadratic formula again. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 4 over 2 times 3. Negative 2 plus or minus, we're going to go 4, then it's plus, because we have two negatives there. 4 times 4 is 16, 16 times 3 is 48, and that's over 6. So now we're going to go negative 2 plus or minus the square root of 52 over 6. Now we have to simplify square root of 52 first. 52 is 2 and 26, which is 2 and 13. So these pair of 2's come out. So now it's going to be negative 2 plus or minus 2 root 13 over 26. Now we can divide these three, and it's negative 1 plus or minus the square root of 13 over 13. Okay, now we move on to our next set. We're going to simplify our expressions. These are negative with square roots or complex numbers. Negative 72. First thing I need to realize is that 72 times negative 1. Anytime we have a negative 1 inside a square root, we're going to put an I out in front. So now we need to look at 72, how we can break down 72. We're looking for sets. 72 is 8 and 9 is a common way we think of it. So we have 2 3s there. Those will come out. 8 is 4 times 2, which has 2 2s, which come out. So it's going to be I, a 2, a 3, and left on the inside is this 2 that didn't have a friend. So it's left inside. When we put it all together, outside I have 6i, and then inside root 2. Now for square root of 96, we're going to do the same thing. It is negative 1 times 96. 96 we can divide by 3. And then that's 32. Now 3 is kind of stuck, but 32 becomes 16 times 2. And 16 is 4 and 4. So we get these pair of 4s there. Those are going to come out. The negative 1 becomes an I. That comes out. And I'm left with these 3 and 2. They're not going to have a pair. They're not going to have a friend. So I'm just going to make them together and write it as 4i root 6. For C, we have 4 plus 3i and 1 plus 2i. I'm going to multiply these like they're binomials. So I use the box method whenever I multiply, and I get 4, 3i, 8i, and 6i squared. So now by combining like terms, it's 4 plus 8i and 3i is 11i, plus 6i squared. But 6i squared, I squared we know is a negative 1, that becomes a negative 6. So now 4 and negative 6 is negative 2, plus 11i. There's our complex number. Same thing now for D. We're going to go 7 minus 3i and negative 4 and 9i. I get negative 28, positive 12i, 63i, and negative 27i squared. Now when we combine like terms, we get negative 28, 63i and 12i becomes 75i, and negative 27i squared. Now same as before, I squared is negative 1, so this becomes a positive 27. So negative 28 and positive 27 becomes negative 1 plus 75i. On our next set, we're going to be using completing the square to solve. So we have to get to this point of completing the square. So off to the side, I'm first going to write x squared minus 4x, and then move the 6 over to the other side. Now whenever we complete the square, we take half of the b value and square it. So half of negative 4 is negative 2. Squared is 4. I add it to this side. I add it to the other side. This now gives me x minus 2 squared on the left side and 10 on the right side, which is kind of what I was looking for. It wanted the 2 there and a 10 there. Now be careful, x minus 2 is what we want, so don't put a negative in there because there's already a negative indicated next to the x. We can finish solving this now by taking the square roots of both sides. I get x minus 2 equals plus or minus the square root of 10. We then add the 2 over, and it's 2 plus or minus the square root of 10. Same thing now for b. I'm going to first write it as x squared minus 16x equals 17. I'm going to take half of 16 and square it. Half of negative 16 is negative 8. Squared is 64, and that's always going to be positive there. So then this will factor the left-hand side to be x minus 8 squared. And then the right-hand side is 64 plus 17, which is 81. So we're going to put a negative 8 there, 81 here. Finish solving it. X minus 8 equals, the square root of 81 is going to be plus or minus 9. We then say x equals 8 plus or minus 9. From here, since it's not an irrational number and there's no radicals involved, you should find both of the numbers, x plus 9, or 8 plus 9 and 8 minus 9. We get 17 and negative 1. For our next one, we're now going to use quadratic formula. It's plugging in the parts. Remember, we have A, B, and C, and pay attention to the signs that are there, positive and negatives. We're going to go negative 5, then it's negative 5, 4, 3, negative 1, 2, and a 3. So plug them all in, now we write it out. We get x equals 5 plus or minus the square root of, negative 5 squared is a positive 25, 4 and 3 and negative 1, well the negative already here tells us it's going to be a positive, and that's a positive 12. Underneath we have a 6. This becomes 5 plus or minus the square root of 37 over 6. Square root of 37 does not simplify, it is an irrational we're stuck with, so this will be our answer. 5 plus or minus square root of 37 over 6. For D, we're going to plug in 2, 2, 4, 2, 5, 2, and 2. So this becomes negative 2 plus or minus the square root of 4 minus, this is 4 times 2 is 8, and 5 is negative 40 over 4. Now it's negative 2 plus or minus negative 36 over 4. Do not reduce these yet. We have to simplify this part as well, which is the square root of a negative. So we have to take an I out. That's 36 is a perfect square. So this actually becomes negative 2 plus or minus 6i over 4. Now we can divide them all by 2, and we get negative 1 plus or minus 3i over 4. Probably should write that in complex form, which should be negative 1/4 plus or minus 3i over 4. Equation, negative 1/2 x plus 4 squared plus 2, and then that's k of x, and m of x is here. So we got to look true and false. Now, I don't need to graph these. I can actually get some good information from this. If I look at m of x, I notice that it goes down, 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 then it starts going up, 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 up. So that means this is the vertex. It also means if that's the bottom, it's a minimum, and it has a range when y is greater than or equal to negative 4. So let's see if that's enough to help us out. Okay, now over at k of x, we have that our vertex is negative 4, 2. Negative 4, 2 is here, so this is k of x's vertex, and it goes down. And let's go 3, negative 4 is the vertex, and this is m of x. All right, so the maximum value of k of x is greater than the minimum value of m of x. The maximum of k is up here at 2. The minimum of m of x is down here at negative 4. So the maximum of k of x is bigger. That's true. We'll say 2 is bigger than negative 4. Okay, the value of x when k of x is at its maximum, so that is negative 4, is greater than the value of x when x is at its minimum. When m of x is at its minimum, which is over here at 3. So that's saying is negative 4 bigger than 3? False. Negative 4 is not bigger than negative 3. Okay, both x-intercepts of m of x are greater than 0. So m of x is over here. Where does it hit the x-axis? Well, it hits the x-axis when m of x is 0. Right here, right here. So they are 1 and 5. Those are both greater than 0. We're going to say true. The line of symmetry for k of x is 4. That is false because the line of symmetry is when x is negative 4, as we're out here in the negatives. And the y-intercept of m of x is greater than the y-intercept of k of x. I don't even need to know what the y-intercept is, because here's why. M of x is going to go up, and it's going to hit, if we just kind of just trace it along, somewhere up there. K of x is going to kind of go like that. Well, m of x is going to hit higher up just by the shape that it follows. So in that case, we know it's greater because we can kind of sketch out the graph. What you could also do is I could plug in 0 for x in both graphs. And it looks like we get negative 6 is the intercept. It'd be nice if I was on the screen. Negative 6 is the intercept for k of x. And then m of x, at x equals 0, it's 5, and 5 is greater than negative 6, so that one is true.